prospective Year 12 further maths students. So if you're at this point, you're at our virtual induction day and you're thinking about taking further maths. Now I assume that you'll already have watched the video for single maths. If you haven't, I really would suggest doing that because that will give you a good idea of all the fun things we do in single maths. Single maths has a lot of algebra that you would never have done before and a lot of really good geometry. However, if you're the right kind of weirdo and you really want even more maths, then further maths is really going to be a wonderful subject for you. You look at things that take you beyond when maths is useful for other subjects, and get into a lot more topics that are just beautiful just for their own sake. Yes, they do have some uses, but their primary focus, I think, for lots of the maths that we have, is that they are elegant, beautiful pieces of maths. And this next topic we're going to look at today is a great example of that. Complex numbers, on the surface of it, seem like such a strange idea to have, made up imaginary numbers. And it just so happens that they're useful. And they do have lots of very, very important uses. To my understanding, they're very, very useful for our understanding of electricity. And lots of the developments that have been made in the last 100 years that involve our understanding of electricity and how electronics work requires complex numbers. However, the reason we have complex numbers is because they are interesting, and that's how they came about. And the fact that they are that they can be useful is a bit of an aside. So what we're going to be looking at today is complex numbers. Okay, let's have a little look. Okay, now we've got a question. What is the square root of a minus number, of -1? Well, you should already know from your GCSE studies that you can't get that answer. Or certainly you cannot get any real number However, we can define an imaginary number. And if we define that as the square root of -1, suddenly lots of new doors open up. Okay, so if we just imagine that mathematicians have their imaginary friend that they're calling an imaginary number, and it's the square root of -1, and if we go along with that, what comes out of that? Well, I squared would be equal to -1. So far, so good. I cubed would be -1 times by I. I to the power of 4 would then be -1 times by -1. It would be 1. Now, how could we think about something like the square root of -4? Well, we could think of it as the square root of 4 times by the square root of -1, or 2i. How about the square root of -100? Again, we can think of it as the square root of -1 times by the square root of 100, or 10i. Now, how about something more tricky? 3 isn't a square number, so we're just going to get root 3 times by I. Now, we've looked at imaginary numbers, but what about if a number has both a real part and an imaginary part? We could think of this as 2 plus 3i, or this is an example rather. It's notation that we often refer to a complex number as z, okay, or z rather, in the same way as we would refer to real numbers as x. And there's a bit more notation there. Okie dokie. Another way of looking at this, or another form that we have, or another way of saying it, is that complex numbers written in the form x plus iy is said to be in Cartesian form. Okay, let's have a look at some problems and see how we can deal, or how we can do some calculations with these new complex numbers. Now, I want you to think for a moment about surds. Can we think back about how we would multiply or divide surds? Okay. Now, what I want you to do is I want you to look at those two questions. I want you to, if you have a piece of paper with you, write down for part A and part B what you would get if you just plugged Z or plugged Z and W into each of those questions, and see, can you think how we could use surds to help us? Okay, I want you to think for 5, 4, 3, 2, 1. Okay. Now, one thing I want to do is we're going to expand and simplify as usual, remembering that I squared equals not 1, that's a mistake, minus 1. Let's fix that. Perfect. Okay. Substitute in and expand. I hope that expansion makes sense. The reason we have minus 9 instead of plus 9 is because minus 3 times minus 3 gives us plus 9, but I times I gives us I squared, which is equal to minus 1. So it's plus 9 times minus 1 equals minus 9. 25 minus 9 equals 16. Okay, let's have a look at our next one. Now, an equivalent complex number with a real denominator can be found by multiplying by the complex conjugate of the denominator. That sounds complicated. However, it looks very similar to what you'll be used to doing when you try and rationalize a denominator with surds. Okay, very good. Let's see, can you use the things or the knowledge that you've just taken in, that we've just talked about, to answer this question here? Okay, can you pause the video and have a go? Okie dokie, let's see if you got the right answer. So first thing we do is we expand. Oh, sorry, it's not expand. First thing we do is substitute in. And then we multiply by what is known as the complex conjugate of the denominator. You'll notice if it's 1 plus I, you do, if it's 1 minus I, you multiply by 1 plus I over 1 plus I. Now you expand, or multiply out rather, and simplify. Okay, well done. Let's go back to the start. So I hope you got that question right, and I hope it gave you a brief insight into the kinds of stuff that we will be doing in further maths. I'm really looking forward to seeing lots of you in September. Make sure you check out the video for single maths, as in that video I talk through what tasks you need to do over the summer so you are ready to begin your studies in September. There's no separate further maths task for over the summer. You just need to make sure you do the single maths task to the best of your ability. Okie dokie, thank you for coming along to this virtual induction day, and I hope to see you all in September.